Question 1. A car travels 180 meters in 12 seconds. We are asked to find the speed of the car. To find speed, we use the formula. Speed equals distance divided by time. The distance is 180 meters and the time is 12 seconds. So, 180 divided by 12 gives 15. Therefore, the speed of the car is 15 meters per second. Now let us look at velocity. A student walks 50 meters east in 10 seconds. We are asked to find the velocity. Remember, velocity is different from speed because velocity includes direction. To find velocity, we use displacement divided by time. The displacement is 50 meters east and the time is 10 seconds. So 50 divided by 10 gives 5. Because the student moved east, we must include the direction. Therefore, the velocity is 5 meters per second east. Now let us solve question 3. A person first moves 4 kilometers north at 4 kilometers per hour. Then the person moves 6 kilometers west at 3 kilometers per hour. We are asked to find the average speed and the average velocity. Remember, average speed depends on the total distance, while average velocity depends on the displacement. First, let us find the time for each part of the journey. For the first motion, time equals distance divided by speed. So 4 kilometers divided by 4 kilometers per hour gives 1 hour. For the second motion, 6 kilometers divided by 3 kilometers per hour gives 2 hours. The total distance is 4 kilometers plus 6 kilometers, which is 10 kilometers. The total time is 1 hour plus 2 hours, which is 3 hours. Average speed equals total distance divided by total time. So 10 divided by 3 gives 3.33 kilometers per hour. Therefore, the average speed is 3.33 kilometers per hour.
Now let us find the average velocity. For velocity, we do not use the total distance. We use displacement. The person moved 4 kilometers north and 6 kilometers west. So the displacement forms a right-angled triangle. Using Pythagoras' theorem, displacement equals the square root of 4 squared plus 6 squared. That gives the square root of 52, which is 7.21 kilometers. Average velocity equals displacement divided by total time. So 7.21 divided by 3 gives 2.40 kilometers per hour. Now we must include the direction. The direction is about 56 degrees west of north. Therefore, the average velocity is 2.40 kilometers per hour at 56 degrees west of north. Now let us look at question 4. A car moves around a circular track at a constant speed of 20 meters per second. The question is its velocity constant? Remember, velocity is not just speed. Velocity also includes direction. The answer is no. The velocity is not constant. Even though the speed remains 20 meters per second, the direction of motion keeps changing as the car moves around the circular track. Since velocity depends on both magnitude and direction, a change in direction means a change in velocity. Therefore, the velocity is not constant. Now let us solve question 5. The Earth's equator has a circumference of about 40,000 kilometers. Earth completes one full rotation in 24 hours. We are asked to find the speed of a point at the equator due to Earth's rotation. To find the speed, we use the formula. Speed equals distance divided by time. The distance is the circumference of Earth at the equator, which is 40,000 kilometers. The time for one rotation is 24 hours. So 40,000 divided by 24 gives 1,666.7 kilometers per hour. When converted to meters per second, this is approximately 463 meters per second. Therefore, the speed of a point at the equator is about 1,666.7 kilometers per hour, or 463 meters per second. Now let us solve question 6. This is an advanced challenge involving a car and a train. The car is moving at 30 meters per second and the train is moving at 15 meters per second. They are both moving toward the railway crossing. The distance between them is 90 meters. The question is, will the car cross safely before the train arrives?
Since the car and the train are moving toward each other, we use relative speed. Relative speed equals the speed of the car plus the speed of the train. So 30 meters per second plus 15 meters per second gives 45 meters per second. Now time equals distance divided by relative speed. So 90 meters divided by 45 meters per second gives 2 seconds. In 2 seconds, the car travels 60 meters and the train travels 30 meters. This means they reach the crossing at the same time. Therefore, the car will not cross safely. A collision occurs at the crossing.